Now, here the question is, name each polygon by its number of sides, then classify if it's a concave or a convex or irregular or regular. Okay, now first we're going to name it by its number of sides. Look at the example here. We have here 1, 2, 3, 4. 4 sides. So when we have a 4-side shape, we can call it a quadrilateral. We will see first if it's regular or irregular. Now we can see here it's very clear. No, they are not equal, and the angles for sure are not equal. Since it is irregular, then it can be concave or convex. Now, how can we test to see? We just try to extend the sides. If when we extend the sides, they come inside the drawing, then it is concave. Then this example was a quadrilateral, it was irregular, and it was concave. Now, let's look at the second example. Here we have how many sides? 1, 2, 3, 4, 5. It is a pentagon. It has 5 sides. It is called a pentagon. Is it regular? Yes, all of the sides are equal and all of the angles are equal, so it is regular. Since it is regular, it can never be concave. It must be convex. Okay, now let's look at the exercise. Here, he wants me to name each polygon by its number of sides, then classify it as convex or concave and regular or irregular. Now, the first shape. This is a hexagon. It has 6 sides, so it's called a hexagon. It is classified as convex because it is regular. All of the sides are equal and all of the angles are equal as they appear in the figure. Okay, look at this rhombus. The rhombus has all of the sides equal, but doesn't have all of the angles equal. This angle is not equal to that angle. Okay, so it is a quadrilateral. This quadrilateral has a specific name. It is called a rhombus, and it is irregular. At the same time, if I extend any of the sides, nothing will go inside the figure, so it is convex, and that's it. Here, this shape is 1, 2, 3, 4, 5. 5, so it's called a pentagon, irregular, and concave. Why concave? Because if I stretch these sides, they come inside the figure, so it is concave. Now this one immediately, the sides are not equal, so it is a triangle. It is irregular, it is convex. This one is 1, 2, 3, 4, 5. It is a pentagon, irregular, and concave. We can see immediately that something pushed it to the inside, so it's clear that it's concave without doing the test even. This figure 2, this concave, it is 1, 2, 3, 4, 5, 6, 7, and 8. 8 is an octagon. It is irregular. Of course, if it's concave, it must be irregular. Regular can only be convex. Now let's look at the second exercise. He wants me to find here the perimeter, circumference, and area. Now, if I look at a triangle, I must find the perimeter, no circumference, and I must find the area. Then, first the perimeter, it is equal to the sum of the sides surrounding the figure. So I have here 3 inches plus 4, so it is equal to 12. So my perimeter is equal to 12, and my area of triangle equals half base times the perpendicular height, the height that is perpendicular on that base. So I have here, it is equal to half. My base can be 4, and my height can be 3. It is equal to 6, and my unit is inch. So since it is area, must be inch squared because I multiply inch by inch, so it's inch squared. This is a rectangle, so the perimeter of the rectangle is equal to the sum of the sides. I have each side is repeated twice, so I have 2 times 2 because I have here 1 and here 1, and I have 3 times 2 because I have here 3 and here 3. So this is equal to 4, is equal to 10. And the area is simply equals to length times width. Now, my length is 3 and my width is 2. So my area is equal to 6 and the units are feet. So it is feet squared. Now this is a circle, so I'm talking about, instead of the perimeter, a circumference. Circumference is only concerned with the circle. It is equal to 2 pi r. My r here is equal to 5, so the circumference is equal to 2 pi times 5. So this is equal to 10 pi, and this 10 pi, if I do it with the calculator, it will give me 31.4 inches. Now, the area is equal to pi r squared. So my r here is 5. So this is equal to 25 pi, which is equal to 78.5 nearly inch squared. So the circumference or the perimeter doesn't have a squared, it's only the unit, the basic unit, and the area must have the squared. Okay, so this is feet still, and this is inch, and that's it. Now we can begin to solve the exercise. Here he wants the perimeter or circumference, and he wants the area, and he wants it all rounded to the nearest tenth. Now, in the first example here, my perimeter is equal to the sum of sides, the surrounding sides, equal to 2.5 plus 3 plus 3.5 is equal to 9. And then the area is equal to half base times the perpendicular height, which is equal to half times 3.5 times 2. And this by its turn is equal to 3.5 centimeters squared. Now look here, this is a circle, so we're talking about the circumference. The circumference equals 2 pi r, and my r equals to 4. So this is equal to 8 pi and 8 pi. Okay, you can do it by your calculator. And the area is equal to pi r squared, which here is equal to pi multiplied by 4 squared, or 16 pi, and solve it by your calculator and round it to the nearest tenth. To the nearest tenth means one place after the decimal point. Here this is a square. I can see that all of the sides are equal. First the perimeter is equal to the side multiplied by 4. 4 multiplied by 14, and this is equal to 56. Then the area is equal to the side squared, which is side by side. So this is equal to 14 squared, and this is equal to 196. Now here this triangle has a perimeter of 3 plus 4 plus 5, which is equal to 12 centimeters, and the area is equal to half base, which is 4, multiplied by the perpendicular height, which is 3, and this will give me 6, and it will leave me with 6 centimeters squared. Now we're going to talk about the area using the coordinate plane. So first we write our rule. Our rule here, we want the perimeter of the circle. Perimeter equals 2 pi r, and we call it the circumference. And we need to know the r in order to substitute in this rule. Now, how can we find the r? We have here two coordinate points. If we join them and we find the distance between them, we can find our r. How can we find the distance between them? We can find it in two ways. Either by the Pythagorean theorem, and this is, I just extend this and then I bring on it this. So it is equal to the square root of 2 squared plus 1, 2, 3, 3 squared. So this is equal to the square root of 4 plus 9 or the square root of 13. This is my length. If I want to find it by the distance formula, it's possible too. Formula, it is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And this by its term is equal to, here we have x2 is equal to minus 5 whole square plus, this is 1 minus 3 whole square. And this is equal to the square root of 3 squared, which is 9, plus 2 squared, which is 4, square root of 13. The same thing. Now, we can use this piece of information in substitution. So the circumference equals 2 pi times root 13 or 2 root 13 pi. Use your calculator, round it to the nearest tenth. And the area equals pi r squared or pi times root 13 squared. Root 13 squared is equal to 13 and pi. And this was my area, unit square. Now I finished this problem. Here I want to find this and I want to find the area. So simply the perimeter is the sum of the sides. Now I prefer to use the Pythagorean theorem because it is more quick than the distance formula. So here I want to find this side. I'm just going to draw to make this a right angle triangle, and this will be the hypotenuse of the right angle triangle, and it is equal to the square root of this side, which is 1, 2, 3, 4, 5 squared plus 1, 2 squared, and this by its term is equal to the square root of 25 plus 4, square root of 29. Now, if I want to find the other side, this was the square root, write it here, of 29. Then the other side here, I will do the same thing. I'll make it a right angle triangle and find it by the Pythagorean theorem. Of course, it's up to you if you want to use the distance formula, if you're not very familiar with the Pythagorean theorem. And here I just count the side plus the other side, which is, here we have the square root of 5 squared, which is 25, plus 1, 2, 3, 4, 5, 6 squared, which is 36. So this is simply the square root of 61. And this one here, I just count 1, 2, 3, 4, 5, 6, 7, and 8. Here I have 8. So this is plus 8. So the perimeter, you do it with the calculator and find the square root of 29 plus the square root of 61 plus 8 and round it to the nearest tenth. Now the area equals half base. We can choose this 8 by the perpendicular height on it. If I bring the perpendicular height, I draw it from here. I just count it. 1, 2, 3, 4, and 5 times 5. And this will give me 20. Okay? Unit square. The third one here, I need to find this distance and that distance only. I will use still the Pythagorean theorem. I prefer it more. Here, I made here a right angle triangle. So the perimeter is equal to, first, the square root of 1, 2, 3, 4, 5 squared, which is 25, plus 1, 2 squared, which is 4, plus the square root of, it will give me the square root of 1, 2, 3, 4, 5, 25, plus 2, which is 4, but they are the same. I just multiply this by 2, okay? And this will give me the perimeter. So my perimeter will be 2 times the square root of 29 plus the square root of 29 times 2, the square root of 29, okay? And this will give me 4 root 29, and solve it by the calculator. Then the area is equal to s squared, but it is equal to root 29 squared, which is equal to 29, okay? Here we're going to do the same thing. You can do them alone. And here we're going to solve this. This is a play area, and he wants to find the perimeter of it. Then he wants to find the area. Now, surrounding this play area, and then we can find the perimeter to make a fence around it. My perimeter is equal to 12 plus 10.8, I think, plus this is 8.4, plus this part, which is 6.6. Then you add all of these together, and you will get the perimeter. Then you find the area. That is equal to half times the base, which is this base, because the height is perpendicular on it. So it is half multiplied by 8.4 plus 6.6 multiplied by the height, 8. You do all of this with the calculator and you find the answer. Now here the same thing. You can surround this figure by a circle, and he wants to find the circumference and he wants to find the area. Now here I know the diameter, so if I find the circumference, I can find it either by putting 2 pi r, and my r here is equal to half of the diameter. So my diameter here, no, this is 22, so it is 2 pi by 22 over 2, okay, which is 11. Then this will be 11 by 2, which is 22 pi, okay? And I can simply do it. This is the perimeter, so it can simply be 22 pi without the 2. Then I want to find the area, equals pi r squared, which is equal to pi multiplied by r. I must bring the r here, which is 2211 squared. So this is equal to 121 pi. The third one is similar. It is a picture. I can surround it by a rectangle. I just add these two sides and multiply them by 2 to bring the perimeter, and then I multiply the length by the width to bring the area. Now in this problem, Ricardo is helping his neighbor improve his backyard. The neighbor wants to install a gate on either side of the house and then fencing around the sides and back of the yard. What length of fencing do they need, including the gates? I understand from this given that he wants to make, this is the gate, part of it is here and part of it is there. This is 3 feet, and then he's going to fence the rest. So he wants to know the length of the fencing. So what does this mean? It's simply kind of a perimeter. The fence, we write here the fence, and gate equals, we're just going to add the items. It's 3 feet plus 18 feet plus 32 plus 8 plus, this was 18, so this is 18 too. I don't look to the 13 only. So this is plus 18. And if we add all of this, it will give me Give me 79. Now, the second part. Next, Ricardo wants to build a triangular garden. What area of the backyard will be covered with dirt for the garden? This is my triangular garden here. Now, this is number B. Now, we want to find the area of this triangle. So, the area of the triangle garden equals half base times height. Half multiplied by base, which is 8 feet, multiplied by 13. And this will give me 52 feet squared to be filled by dirt. Now, the last question is Ricardo will cover the rest of the yard with grass seeds. What area of the backyard will he need to cover with grass? This area, the green one. So I'm going to bring the whole area first and then subtract the area of the triangle from it. So the whole area is the length times width, which is 18. The area total equals 18 multiplied by 32 plus 8, which is 720 feet squared. And then to find the area of the green, the area of the green part equals the total area, 720, minus the area of the triangle, which I got here, minus 52, which is 668 feet squared. Now, in my last problem here, an art classroom has both rectangular and circular tables, as you can see here. Okay. The teacher plans to cover each table with a sheet of paper for students to work on. What area of paper should the teacher cut for each rectangular table? What area of paper should the teacher cut for each circular table? Round the answer to the nearest tenth if necessary. يبقى first we want to find the area of the rectangular table. Here we have the rectangle. It has 6 feet by 2. That is equal 6 by 2. And this is equal to 12. Then he wants to find the area of the circle, which is equal to pi r squared. We need to find the r. Here he gave me, if I make this a little bit bigger, this is the circular table. He gave me that the diameter, which is all of this, is equal to 2 feet and 6 inches. Okay? So we need here the radius. We don't need the diameter. So first we need to find the radius, which is the diameter divided by 2. Okay. Now my diameter here equals 2 feet and 6 inches. I must transfer the 6 inches into feet to be able to divide it. So I know that 1 foot equals 12 inches. So if I have 6 inches, how can I transfer them to feet? So I'm simply going to do cross multiplication, and it's going to give me question mark equals 6 divided by 12, which is equal to half a foot. I'm going to take this half foot and add it to the 2 feet. So my diameter here was equal to 2 feet plus half feet. This is equal to 2.5 feet. Now I'm going to take this piece of information and put it in this rule to find the radius. So my radius here will be equal to the diameter, which is 2.5 feet now, and I divide it by 2, and this will give me 1.20. Okay? Now I'm going to put this in my main rule. The area of the circular table equals pi multiplied by 1.25 squared. So of course you're going to use the calculator in calculating this amount, and then by this we finish this part of the question. The last part, there are 12 identical rectangular tables and 6 identical circular tables. What is the total area of paper needed for all of these tables round to the nearest tenth? Okay, now we know that the area of the circular rectangular table is area total equals the area of rectangular tables plus the area of circular tables. But this is equal to 12, which is the area of one rectangular table, multiplied by 12, which is the number of rectangular tables that we got from the problem here, plus the area of the circular table, which is the one that we didn't calculate yet, pi, multiplied by the number of the circular tables, which is 6. So the total area will give me 144 plus, if you do this part by the calculator, 6 multiplied by 1.25 squared multiplied by pi, and find your final answer. This is the total area needed of paper to cover the tables. Thank you.